Good morning, physical science for students, wherever you are. We can't let a little problem like a lockdown stop us doing the practical work that's required in the course. So I'm going to be taking you through Lab Prac 4, which is about specific heat capacity. I'm going to be finding the specific heat capacity of a solid, that's glass, and a liquid, methanol. I'll take you through all the steps, and then you take the measurements, do your calculations. The video is a little choppy, but I'm making it on my cell phone. During a lockdown, you've got to do the best you can with what you've got, and I'm sure you know what that means in your situation. So here we go. Watch the steps. You are, after all, learning a method of doing a measurement. It's not really an investigation. What we're trying to do is to see how close we can come to the accepted value of the specific heats of these substances. So the substance that we're going to be working with is glass, and it's in the form of these two glass marbles. Well, we need to find the mass of the marbles. So for that, we use the rad mass microbalance. Here it is. This is the microbalance. It's an electronic device, and it's quite sensitive to 0.1 of a gram. Let's switch it on. When we switch it on, we have to adjust it so that it will read 0 with nothing on the pan. So we have to switch it on and then tell it that there's nothing on the scale. There's nothing on the balance. Switch it on. You'll see a little that says we're measuring in grams, not carats. It starts happily looking for its 0. So we're going to press the tare button, and that is nothing. Okay, to be happy with that, put on. And with the measurement of the mass of the glass. Now we have to heat the glass. We have to put energy into it. And we're going to use the RadMass microscience kit. That's the combo plate. There's the burner. And this part is the heating stand, which we'll put in here. We want it fairly high because we don't want the water that's going to be in here to boil too fast. Right, so we're going to put in the marbles. There's the glass. And we're going to add some water. We'll leave a little bit of a space at the top so that this water is going to boil, and we don't want it boiling over and putting out the flame. Let's light up. A calorimeter is a device which enables us to measure the amount of energy transferred from one substance to another. And this is the kind of calorimeter we're going to use. It's two polystyrene cups, one inside the other, and then a thermometer and a cup that has been cut down to fit into the first two. And then when we have it like that, we'll be able to see the temperature of whatever is inside the calorimeter. And of course, we're looking for temperature changes. The calorimeter is going to hold a certain mass of water. So we need to find out what the mass of that water is. We can't pour the water onto the scale. It's got to go into here. So let's find out what the mass of this is to start with. Okay. Now we need water in the calorimeter. We're going to put in just enough to cover the marbles. That looks about all right. And we want to make sure that the thermometer will actually reach down into that water. So what mass of water have we got in here now? We'll have to find it on the scale. Now we must find the mass of the water and the calorimeter. You got that measurement? And now we need the temperature of the water in the calorimeter. Let me try and zoom in and see if we can get that. Boiling water. The water is heated. The marbles are in the boiling water. Let's check on the temperature of the boiling water. Now we've got the marbles to 95 degrees, which is the temperature of the boiling water. They've been boiling for quite a time. Now we're going to take them out and put them into the calorimeter. We just want the marbles, not that water, and we quickly close the calorimeter. Now the marbles are in. We need to swirl it around. Can you hear the marbles rattling around in there, around the thermometer? Get that water moving all around the thermometer. And then we can come in and we're going to have a look at the temperature reading now. Let's try and zoom in as much as myself.